This is a short flipped mini lecture on scalars and vectors. That's night 3.1. This ruler here has a length, about 30 centimeters, or about 12 inches. Forget that for a moment, just for a moment. This thing has a length. That's a concept that existed before we assigned a number to it. And all sorts of things that you know are true about lengths. Like if I took two of these and I put them end to end, I'd have something with twice the length. Or if I cut it in half, I'd have something with half the length. All those things were true before we introduced centimeters or inches or anything else like that. Now we're going to introduce that. Something that can be represented by a single number, including units, by the way. Something that can be represented by a single number we call a scalar. A good example of a scalar, a great example of a scalar, is a length. And this thing here is about 12 inches in length. Maybe I'll use the letter L for that. So L's 12 inches. Or if you prefer centimeters, L is about 30 centimeters. Or if you prefer meters, L is about 0.3 meters. Now let's go on to the idea of a vector. A vector, the most classic example of it, is a length and a direction. So if I say, go over there 15 feet and start digging, you'll find the treasure, that's a good example of a vector. And things that you know are true about vectors come from that interpretation. If I say, go over there 15 feet in that direction, and then dig down 6 feet, well, it makes sense that going there that way, and then from that point continuing downwards, can make a combination of two vectors, which tells me really where to find the treasure. It's that way 15 feet and that way down 6 feet. Together, you can kind of say that the treasure is off over that direction. And some interesting things are true. For example, going down 6 feet and then over 15 feet would also be a way to get to the treasure. So, this would be a great example of a vector. Go west 15 feet. And another vector, go down 6 feet. Okay, and the way we draw these on the board is usually we draw them with arrows like that. Now the idea of going west 15 feet does not really capture where the business about where you started. Going west 15 feet can be done from here, or it could be done from here. If I go west 15 feet from here, or I go west 15 feet from here, I end up in a different place. But the idea of going west 15 feet is what's captured in this idea of a vector. And where I started is a whole nother thing, okay? And going down 6 feet is another thing that can be captured. I could go down 6 feet from right here. I could go down 6 feet from over there. Going down 6 feet is a good example of a vector, and it does not actually capture where you should go down. All right, now here's an interesting thing. If I go west 15 feet and then I go down 6 feet, that actually gets me to the same place as going down 6 feet and going west 15 feet. And if this entire thing here is captured by this symbol A, and this entire thing here is captured by this symbol B, then what we've really said, and if this is sort of means A plus B, like go this way and then go that way can be captured by this, a plus b. What we've really said here is it doesn't matter what order you add a to b or b to a. So the bottom line of Night 3.1 is that there are two very different kinds of quantities that we're going to be working with an awful lot. And they're scalars and vectors. And because they're so different, usually we just make a nice sort of letter symbol when we're trying to capture a scalar. When we're trying to capture a vector, in order to distinguish it from a scalar and emphasize that it is not just a length, say, but a length and a direction, to emphasize that it captures more than one thing, to emphasize that if you want to write it down in terms of coordinates, you're going to need more than one number, we usually write it with a little arrow sign over it. Knight is consistent. He always puts the arrow sign over his vectors. And now, here's something I want to say. I want you to be consistent. Okay, it's not enough for me to just communicate to you that I mean that this is a scalar and I mean this is a vector. One of the things I absolutely want you guys to be doing precisely is thinking about whether any given quantity at any given time is a scalar or a vector and using the correct notation. As things build up, it's important to have these very distinctly in your mind.